So we have two expert speakers from Chogori Technologies, Mr. Dominic David and Mr. Kelvin Ng, who will discuss the fundamental of connectors, application areas in electric vehicles, and important parameters, different varieties of connectors. The agenda also includes a brief on Chogori's latest connector offerings for charge, discharge, and battery swapping for electric two-wheelers and three-wheelers. The session will have a designated segment for audience questions and answers towards the end. So as audience members, if you have any questions, you're welcome to use the Q&A box to submit your questions for our experts. So without much ado, let me quickly invite the first speaker, Mr. Dominic David, who's a senior manager at Chogori, to start his presentation. Over to you, Dominic. You may share your screen.
Hi, good afternoon, ladies and gentlemen. Yeah, my name is Dominic and I work for Chogori Technologies. We make waterproof connectors, for rugged environments, and also including electric vehicles, which we are going to talk about today. Okay, so Chogori is certified IATF 16949 facility, which is in line with the quality management standards of automotive industry. And today we're going to discuss or talk about the connectors. Okay, so let's start, guys. Just a moment. Let me share my screen. Can you see my screen?
Yes, Dominic.
Yeah. Make this bigger. Okay, so let's talk about connectors. Understanding connectors. Let's start from there. Okay, so what are connectors? Connector is basically an electrical connector as an electromechanical device used to join electrical conductors and create an electrical circuit. Most electrical connectors have a gender. They call it male component, sometimes called the plug, or a female component, sometimes called the socket. So you may know a lot of connectors already everywhere. Like, for example, here, a computer tower, which is the CPU of a desktop computer. At the back of that, you see a lot of USB connectors, which connects to peripherals like the mouse, keyboards, and printers. Also others like HDMI ports and the power connector here. So we're not going to talk about these type of connector, but for our application now, let's discuss more on how connectors are used on electric vehicles, specifically for two wheels and three wheels for scooter market. Okay, so a connector is going to consist of conductors, where on the left here you'll see the male pin, and on the right you're going to see the female pin. Okay, so these conductors will then be assembled into what we call an insulator, so that is going to be separated from each other and insulated from each other. From there, this will be the insulator here, which is what we also call a housing, connector housing. Okay, so a connector for an electric vehicle usually is what we call a hybrid waterproof connector. We call it a hybrid because it is consisting of power pins and also the signal pins, because as you know, mostly all our electric vehicles now are smart connectors, smart vehicles that has a signal transmission as well. Okay, so for a waterproof connector, you need to have some sealing there. You can see we have an internal O-ring, and this is important to keep the elements entering the connector, like water and moisture, things like that. Okay, so the connector will consist of a plug. As you can see here, this is what we call an overmolded connector. And then its mating pair will be the socket, the female socket, or also called a receptacle, which usually goes to a panel, sometimes like, for example, a battery. So this is going to be installed into the battery and then screwed up. And it should also be sealed with a gasket, if you can see at the back side right here. Okay, so this is a basic introduction for a connector used on a two-wheeled electric vehicle. Okay, so let's talk about more. How is the connectors being used on an electric vehicle? Specifically, now we're talking about this two-wheel scooter. Okay, so if you can see here, this is a battery which has a two connector system. A very simple representation here shows that one of the connector, there are two connectors. One of the connector goes to a discharging plug. Okay, discharging means it's going to draw power from the battery going to the motor here. Okay, so the other connector goes into a charging port where if you finish using the bike, you can go home and charge it to the power plug at home. Okay, so that is for charging and discharging. Okay, so let's talk about the common connector requirements for an electric bike. There are 6 points here that I want to talk to you about. They are quite important also. Number 1 here, this the connector should be a high current rating. A high current rating, it doesn't mean that it needs to be always high current. It means we need to know what is the current carrying capacity that will be required by the vehicle or by the battery that's going to be supplied to the vehicle. Okay, so that is depending on the battery capacity, of course, and then as well as the discharging of the motor power and considering the peak as well. So from these points, you need to have and you need to know that the current carrying capacity of the connector, it has to be considered. So a current is being affected by the sizes of the contacts itself. Okay, so for example, a 3.6 millimeter diameter pin can go up to 50 or 60 amperes. Okay, while a 6.0 millimeter pin contact can go up to 120 amperes. So what I'm talking about is this one here. Oops. This one. So that is why you will be able to see some of the motorcycle, if they have a lot of big motors that goes up to 1 kilowatt, for example. So you need to have a much bigger connector there. So the second one, it needs to be reliable in a vibrating environment. Okay, vibration can greatly degrade a connector's performance over time. So the causes of vibration on a connector is, one example is a fretting. Okay, fretting leads to corrosion and wear, and also the relaxation of the contact forces is the most common issue. When this occurs, it increases the resistance of the contacts. So fretting, it happens whenever the connector or the contact, when it's mated together, when vibration is present, these two metals are going to rub against each other. Very small micro vibrations that we will not be able to see usually, but in time, because that high vibration setting that happens between these two and the friction occurs, then the plating of the pin is going to be removed. Then once plating and exposed conductor, when the conductor is exposed, oxidation occurs, and then later on corrosion. Okay, so temperature rise. Okay, temperature rise requirement is also important. So as you know that these conductors are made of a metal, and the metal is a malleable material. In terms of temperature, once it becomes hotter, more malleable, and it means that the electrons is much more harder to pass through. Then the performance is going to degrade as well. Then conductor resistance is going to become higher, which is not very good. So this needs to be considered as well. Okay, the next one will be waterproof rating. Waterproof is the main concern for electric vehicles now, because we're going to use the bikes outside. Sometimes it's rain, sometimes some places are flooded. So a good waterproof connector means it needs to avoid moisture, and then avoiding that moisture to come in contact with the pins or contacts, and then decreases the insulation resistance. And also, of course, it's going to corrode over time. So yeah, one example of a waterproof rating is IPX7, where no water intrusion under 1 meter of submerged underwater for 30 minutes. Okay, the next one is the connector needs to be easy to lock in and lock. With a wide range of people going to use the vehicle. So this is more on consumer experience, how easy it is for a lady to use it, or even for a guy that has a big hand to use it properly, or smaller hand, then needs to be considered from a target market perspective. Okay, so the last one here, the requirement is high mating cycles. So considering a 1 mating cycle, it means 1 plugging of the connector plus unplugging, that is equals to 1 mating cycle. Okay, so this needs to be considered because depending on the battery life and the mating cycles, due to charging when you remove the connector, it needs to be reliable and meets its usage. For example, if they say that the battery is going to last for 5 years, and every day it needs to be charged 1 time. So the connector mating cycle should meet at least 1,825 times. Okay, so maybe more, then it is something that for contacts needs to be treated, different treatment process. Okay, so these are all important aspects that whenever you develop a battery for an electric motor, then are important to consider these points. Okay, so of course, once you have those points considered, once you are going to get a supplier for your connectors, then you need to know or understand that the requirements needs to be met. This is by testing using an appropriate lab that can do something like a simulation from all those requirements I was talking about earlier. A good test plan must be in place. So this needs to be worked together from the engineering perspective on the development of the bike and for the connector, of course. So this is an example one, a US car 37, which is one of the automotive standard testing plan. Okay, like for example, here we have a vibration test, thermal shock, temperature, cycling. One example here is a vibration, where vibration test is going to be done with 10 samples here. And then these 10 samples will go into sequence of tests. So this is number 1, is going to be done a test of visual inspection. Okay, and then the next step will be number 2. Number 2, we're going to test, should be this one, connectivity cycling. Okay, going to test the connector cycling. And then number 3, we're going to test the continuity monitoring. So if you can see, the number 3 step is going to be testing 2 tests at the same time. Number 3 will be also being tested vibration. So while doing vibration tests, it needs to be monitored of circuit continuity, making sure that there's no cut in electrical transmission there. Okay. After that, number 4, we need to test the voltage drop. If there's any problem with the contact resistance, this is tested as well. Number 5 will be the insulation resistance test. And then the last one, we go back to check the visual inspection. Just the simple background of explanation about this test matrix. Okay, if we didn't do any of those tests and requirements that I was talking to you about earlier, we can face these issues for these connectors' performance. If you can see, some of these are burning up, the connectors are burning up, some of the cables are being disconnected because they're not really fit for that type of application. Like, for example, this one, it's not waterproof. Okay, some of them, like, for example, this connector here, it's really corroded because water went inside. Sometimes there are assembly issues, which you can see this pin is falling off, and also breaking insulation, if you can see here. Okay. So, of course, from all these, you need to go from the basics. You need to choose the right connector. So choosing the right connector, for example, this is just to show you some comparison. When you're using a traditional connector, which you see in the picture here, sometimes some electric bikes are still using this type of connector, which is similar to what you see of a connector used on the TV or even at the back of the computer, right? So their current rating is small, okay? They don't have environmental protection. Mechanical life, it's really low also. They don't have vibration test done here. Pull-out resistance, no. The size is big and it has no signal transmission. So you need to choose a connector that fits into the requirement, like choosing the correct current rating, waterproof, mechanical life that I have explained earlier. It needs to pass vibration, pull out resistance. The size needs to be small to fit into those small spaces that we usually encounter when you're designing the bike. And of course, signal transmission needs to be there as well. Okay, so just some example to show you what are different connectors used on different batteries. If you can see here, this battery is having two connector systems, similar to earlier discussion. One goes to a discharging and the other one goes to a charging. Okay, so usually for a discharging connector, it has more pins because this needs to also have some additional uses for signal pins, like for communication. Okay, so for battery charging, we don't need usually a communication pin, but a lesser pin and a lesser current rating is involved for charging. So it's a smaller one. And of course, once you wanted to have a charging connector or a charging port, for those onboard chargers, it also needs to be, it should also be waterproof and can avoid water like when it's raining. So a cap or a cover needs to be considered. Okay. So this is another example of a different battery which only uses one connector here. This connector is used for both charging and discharging. So this is an example of a battery which only using one, where it's connected already to the the vehicle's control unit. Okay. So yeah, so earlier we're talking about charging, onboard charging, but now this is a different charging way, which is using a charging station. Okay. So this one is using a charging station that uh, what they call a swappable solution. You don't need to charge it at home, but you can bring it to a charging station. You just pay the fee and you can plug the drained one and get a freshly charged battery. Okay. So other application, if you want to charge it at home also, of course, the charging equipment is going to be provided to you. You can charge the whole battery at home. Okay, so other applications, as you see here, this is a different type of connector, which is a twist type, but the battery inside is only using one single connector. Another one here using a single connector for charge and discharge for Okinawa. Okay, so others, like for example, this app scooter from Etergo before was Etergo company. Now I believe it's Ola. It was using battery or removable batteries before. And now this new design is a fixed battery inside using the same connector. Okay, others similar. Now there's an onboard charger here, which is located right below the seat there. Similar application. This is an e-bike where it's using a suitcase style battery which goes inside and provides power for delivery of the post. Okay, other delivery services like this one, an e-cargo bike. Okay, and others for connector design, you need to also consider how are you be able to handle the connector to remove it properly. So one example here, because the space of the connector inside the vehicle is too small. You can see that. Then you need to consider some other designs of the nut to be able to remove or unlock it to have a better finger access. As you can see, this nut right here has this small ear to remove it properly. Okay. So all those charging stations have different designs, such as this one here. Where they just put the battery into the slot and then connect the connector together and then get a new freshly charged one. Okay. So of course, different types of business for these charging stations, those that we're talking about earlier is that the user can change the battery itself. But this type of design is where the rack, the battery rack is located inside a convenience store where you bring your battery and pay the fee to the sales lady, and then they're going to get the battery for you. So it's a similar type of design where they just slide in and then connect the connector there. Okay. So those connectors that I was talking to you earlier, this is called a large series. Okay, so currently rated at 50 amps for the power with different nut design, if you can see here, for finger access. So other connector, are available in the market as well. So different design. So this type of design here is where the flange is actually flushed to the battery. The advantage of this is that the overall depth of the connector is going to be reduced. It's much more lower form factor. The height is lower. Okay. So other connectors available as well, like for example, this KR2+6, where there are two types of connection system. You can use the same connector, panel connector, to use two plugs with different locking mechanism. You can use the flip lever here, and or you use this nut, a locking nut. Okay, as you see, now all the connectors are becoming bigger and bigger, because this is like I said earlier, it depends on the motor power. So sometimes if you're using a bigger motorcycle, especially for those public vehicle motorcycles, it will require much more higher current rating. The difference for a higher current rating, of course, is going to become bigger because the pins are going to be bigger. So this is one example, Panga 100. Okay, so others, it's also become bigger, a different type of connector with a lever. It's called Kunlun, where it goes to 250 amps. Okay. So all those connectors I was telling you earlier, those are mostly on the plug and cable side. So there are other options of connector where what they call for a swappable or replacement battery connector. Okay, where one part of a connector goes under the battery and then the other one goes to the vehicle here. Okay, if you can see, the design is quite different because there are these two aligning pins where once you put the battery in, these pins are going to align to those socket there. Okay, and this is designed to where you can put the battery bi-directional. It means you can put a different direction, 180 degrees can be, there's no problem with the polarity of the bike, of the battery. Okay, so these type of connectors, what we call a floating connector. It's similar to that one I was talking to you earlier, but this has a video to show how the floating function works. You see the movement there on the connector. This means it has a little bit of play where it's going to compensate once the battery slot has some tolerance of movement. So it's still going to align itself. It's self-aligning, okay? So a similar application for this, as you can see from this charging cabinet, and the connector is present all on the bottom of the battery. And the mating pair, of course, will be on the vehicle itself, and at the same time, the same as this charging station. Okay. So others, there are a lot of this in the market today. So where they just get the battery, put the drain battery into the slot of the charging station, and then put the payment, and then you can get a new one. Okay. So of course, it's not just on the connector on the battery. There are lots of connectors that needs to be considered because all of the requirements needs to apply to all. Like for example, this is just a simple connection system showing to you it has a USB charging port where you can charge your devices. And there's a charging port for the battery itself, and also a charging cable that connects to charge the vehicle. Okay, so not just on the battery connector, you need to consider the waterproofing for everything on the inside as well. So sometimes the bike might go into the flood, or water splashes needs to be considered, where it's not going to enter moisture inside those conductors or the cables as well. So a waterproof splitter is very helpful to make the cable or organization better. This is another example of a cable connections inside of, this time it's an e-bike. Okay, as you can imagine, a scooter is already a big one, but we don't have much space inside. But for an e-bike, which the cables are going inside the frame, you need to design a connector based from all those limitations. So if you can see, this has a charging port. There's a connection to the internal battery of the bike, going into a splitter charging port, and going to the other parts like the motor, going to the sensor, and to the display. This is an example of the display. This one is what they call a range extender. So if your battery, internal battery drains out, you can get a new range extender to give you more duration of the ride. Okay, so this is the charging ports. And this is an example of a waterproof connector on a motor. So if you can see, using this type of connectors in the bike, it's quite challenging, because it's going to be all used on mud, on water, due to rain. So it needs to be very robust and waterproof. So those are just some of the points for all the connection systems used on a lot of different electric vehicles right now. So it's not just on the bikes and scooters, there are also micromobilities, many micromobility aspects and market. So thank you very much, guys.
Thank you so much, Dominic, for that very insightful presentation. I'm sure all the audience members took a lot of learnings from that. So next we will move on to Mr. Kelvin's talk. And Dominic, in the meanwhile, there are a lot of questions in the Q&A box. Some Kelvin has answered. And if you could take some time to answer a few of those, that will be great.
Yes, yeah, sure, guys.
Thank you. Kelvin, I would request you to share your screen, please, and tell us a bit more about Chogori and your capabilities.
Yep, Priyakshi, I already shared my screen. Can you see the screen?
Yes, we can. Please start. Yes.
Okay, just a minute. Put this over. Okay, a very good afternoon to all online participants to this webinar. My name is Kelvin Ng. I'm the sales leader taking care of the overseas market. A lot of my concentration of activities currently is in Europe, as well as the Asia Pacific region. So my presentation is to let the team know a little bit more about Chogori, and then some of the history and milestones of the company. Okay. Okay, Chogori. We are basically located in South China, founded in 2007. And then there are many customers that historically also ask how did the word Chogori actually come about. So Chogori actually represents the local name for K2 the second highest peak. And when the boss of the company came out with this name, Chogori, it was intended more like we are always number 2, serving the customer at the top. Okay, that is how the inspiration of the company came about right at about 2006 into 2007. And that's where we were founded. We're located South China at the moment, and then we have a very long history starting. I mean, we are still a very young company, but we started doing a lot of environmental connectors, hazardous environment, outdoor applications. This became the backbone of the company. So there's a lot of milestones that we set, including also a lot of lighting-based projects for the Olympic Games, the World Expo, the Shenzhen University Games, that brought us to be more and more known in this market. So a lot of the things that we do in lithium batteries, those involving also LED street lightings, industrial automation, marine, we have a lot of different market segments in all the products that we do. So as we get into EV markets, starting from a lot of four-wheelers in the Chinese domestic market. So we were also thinking about, there wasn't a very defined standard. Even today, a lot of the electric two-wheelers, I see a lot of questions that is asked, what are the standards? There's no defined standard at this moment. The various country governments are trying to define. So along the way, we also work with all these consortiums to make us the best that we can, a part of those standards. Okay, so I will share a little bit more with regards to this area in the later part of the slide. So the development of the connectors that we do, you saw Dom presented, we also follow a certain standard. The only standard that we can reference at this moment is US CAR 2, US CAR 37 for all our development efforts. Okay, and now we also adopted the lean management. Our production floor, the entire company, we are running a lean operation. And this started right at about 2013. So we can have very little people that we can produce parts in a very quick time, all based on a single piece flow. So a lot of customers we work with in India are also lean experts that gave us a lot of advice how to make our products better. Okay. So the various milestones here, I will not go through all of them. It's just 2008 was the first major break from the Olympic Games. I'll show a little bit on that picture in a moment. Then 2010, the Shanghai World Expo, progressively until where we are today. So we really expanded into a new operation site in Dongguan, about an hour north of our current location. Then we are working to expand the operation this year in the new facility. Okay, so we are starting to move a certain production, starting to work up the scale of this location in Dongguan. Okay. So, like I mentioned, we are specialists in a lot of difficult environment connectors. So we have a lot of history built up in this area. So these projects here are a part of the milestones that we had. This became a China national standard that we have also allowed give our patents for others to also build. So this started where there was a lot of different systems, different standards, and then finally the Chinese government adopted this M15 as a standard interface for street light. So, and then now we also have another set of solutions that the Chinese government is considering to make it as a standard for the areas on electric two-wheelers. Okay, so this is still ongoing. Okay. Then that's where we all these projects here are a lot of work involved from the top left. Okay, the Olympic opening, the major scroll, 200,000 sets of connectors on that scroll at the back. So a lot of connector suppliers that bid for the project. So we got this project because there was a very strict requirement on waterproof. So a lot of the connectors tested, and we passed the test. So we ended up in this space. And there's a lot more, the bird nest in the 21.4, and then also a lot of the landscaping. So we got to be very known in all these LED lightings that we also extended into agricultural areas, grow lights. And we are also starting to gain a lot of attention in this market. This is more on the global, different customers. Then this market is also gaining a lot of attention. We supply a lot of this in the US, in Asia, very specific to a lot of GPS, a lot of fleet tracking, can be containers, can be trucks, to identify the location. Okay, so we gotten to be quite a bit of concentration in these markets also. Okay, then we are also very big in this all these water meters, and this market mainly is coming from North America. So we have a lot of volume moving for this kind of solutions, which some of them are underground. Okay, so we need to make sure that the whole waterproofing requirements meets all the expectations in this area. Okay, and this is the one I was talking about. Currently, we don't actively promote this range outside of China because of different considerations. If you put a cable, it is very heavy, and then there are other considerations that we have. So currently, we only promote this range of products more for the domestic market. And you see already from what Mr. Dominic has presented, we have got a fairly long history already in this e-scooter market. Again, same thing, leveraging from our earlier legacy product, we extended into this market segment. So, and then we have a lot of global representation. A lot of customers know us in this market. We even for Europe side, we have a lot of customers. Even for China, we work on certain standards with the local government. Okay. Okay. And e-bike, we're also starting to gain quite a bit of attention, working mainly for this market, mainly more for Europe. Okay, we have a lot of this is a booming market in Europe, so we ended up with very small connectors, okay, that needs to go in and out of the bike frame. So fundamentally speaking, we do things from very high current all the way to a very small signal base. And I see certain questions coming from the floor also, just to address one or two of them. A lot of our solutions are basically hybrid. So we pack power and signal into a very small form factor. This is the first thing. The second thing is we develop our own pins and sockets, and we have patents also to some of the higher current sockets that we use. Okay, so a lot of India OEMs that we work with are quite familiar with our overall capabilities. Okay, so this part is also an extension to what Dom mentioned, and we follow a very rigorous APQP process from the time that we engage the customer, understand what the customer needs, all the requirements, all the various parameters. Someone in the group asked a question about performance versus life expectancy. So things like this, okay, we need to get to understand about all the parameters that the customer expect, the number of mating cycles, the contact resistance, and then correspondingly what they expect in terms of the temperature rise, and so on. So there's a lot of iteration. If we come up with a custom solution, there will be a lot of iterations we need to run with the customer until we get everything all fully approved through 3D sampling, through prototyping, and then PPAP, pass approval, prior to the mass production. Okay. And like I said, at the connector level, this is what we can do. We can only reference a certain spec. So we use the US car automotive standard, using this particular test matrix to rigorously test all our developments that we do in our factory. Our factory not only produce, we are a very a whole entity where we do our R&D. We have our own test lab to develop all the connectors and have it properly tested. And then some of which customer requires certain UL, certain TUV standards. Then we also get it finally approved through third-party labs. Okay. Okay, this would be the very quick sharing from my side from the overall overview on the company side. So my email is in there. So please you can drop me email or and I will come back to you with all the questions that you can have. Okay. Okay, that's the end of my presentation. Priyakshu, back to you.
Thank you, Kelvin. Thank you for the presentation and also for answering the questions in the Q&A box. I can see Dominic is still answering some questions, but I will just, for everybody's benefit, I will just ask the questions that are coming very frequently. One question is about your distributorship model in India. Do you have authorized dealers? And if somebody is interested in the products, how do they get in touch?
This is a good question. Actually, because we have partners that we work with. We do have. Okay, they are based in Hyderabad at this moment. But I'm also looking to expand potentially to more partners as we move forward. So for now, can reach us directly either through Elena or through Bobby. We can share their contacts and email after this session. Priyakshu.
Kelvin, can you put those emails in the chat box so that everyone can have access to them?
Okay, I can do that. Maybe I can just quickly ask Elena to do so. Elena, can you put your email and Bobby email in the chat box so that all the participants will be able to reach at least one of you?
Okay, while she does that, we can go to some of the other questions. Another question that is coming frequently is there any solution for a fast charging connector?
Dom, you want to answer the question?
Can you say again, Priyakshu?
The question is, yes, the question is whether there is a solution for fast charging.
For fast charging?
Yes.
Yeah, so for fast charging, it will be depending on how much current rating is going to pass through. So usually for a charger on a battery, for example, it is going to charge the battery in a comfortable state of the charging, for example, 3 hours or 4 hours. So once you want to increase or make this into like a 1 hour, then you need to put more power into the battery. So this is something going to be on a system side design. Of course, you need to get a proper BMS to be set up to be able to accept this sudden increase of power that is going to be provided. So it's more on a system side of a question, but of course, on the connector, it needs to be able to accept that incoming power. So yeah, that's it, I think.
Okay, maybe I can just add on a little bit more here. Okay, typically for for charging is actually lower, depending. Depending also on whether you're going to go with an AC or you're going to go with a DC. So today we have had solutions in which a single connector. There was a question that was raised. A single connector that we can do a big gauge cable to do discharge. At the same time, that same connector we can change to a smaller wire gauge in order to do charging. Then another part to answer is we did have GB standards for like charging guns, including also Type 2 that we have developed. But as this evolved, there is new IEC standards, 62196-5, now becoming -6. So we're also discussing with some customers, India customers, whether there is this very strong drive from the government to go with -6. Okay, we already have a lot of these developments done on the -5 previously. So we can extend it very quickly, but we need to have a fairly strong confidence that this will be the standard, something like this. Okay. Yeah.
Okay, understood. So there are other questions about standardization again, because when we talk about standardization in connectors, we compare with four-wheelers because there are specific, very well-defined standards in four-wheelers. But in two-wheelers case, we see that different companies are coming up with their own configurations. So why is that? And do you think from your experience in the field, there will be some kind of connector standardization in two-wheelers and three-wheelers going forward?
One thing that we did experience over time is certain standards will evolve. So it's the same like when we did the street lights, then we ended up with this very strong drive to make the M15, the 2-pin, becoming a standard. Then the Chinese government has got certain requirements. Okay, so they got both in the definition of swap. Okay, we always try to make clear also. So the swap can be a cable or without a cable.
Yes.
So yeah, so the Chinese government has got a couple of these options also. And what you saw in the KR2-6, the KR2+6, the 2 power plus 6 pin, for a 40 amps continuous discharge, the one became a part of the Chinese standard. Whether finally it will be 100% formalized, the one I cannot comment at this moment. But our solution has been adopted into that requirement.
I see.
Yeah. On the KR2+6, and in Dom's presentation, it was presented earlier.
Okay, but the connector requirements in China, and when you compare them with the OEMs requirements in India, I'm sure they will be very different, aren't they? Or are you thinking the same standard that if it is adopted in China can make its way to India as well?
Yes, I personally believe so, because the many OEMs and the many different customers that we work with, the battery operating voltage and what they require for the discharge, our connector solutions can fulfill those requirements. But we are also getting more and more requests from the customers saying that, okay, can the connector take up to a higher peak current, for example, at a certain exposure, something like that. So for some of those requirements, we would need to rethink. From the connector point of view, we need to do some additional tests to make sure that things are okay.
Okay, right. There is one more question from Mr. Shubham, and it's specific to the Indian conditions. What is the possibility of mating connector pin damages due to Indian road conditions? Because we are assuming there will be more vibrations if the roads are not even. So how do you work with that requirement?
Dom, you want to answer that question?
So, okay, this is regarding vibration.
Yes, because of uneven road conditions.
Yes, yeah. So For connector industry, there are a lot of standards available also. So there are like SAE, US car. There are also IEC standards, but mostly for those, it is more. You need to get more into the details of where is going to be applied. Of course, like for um, Indian roads, for example, sometimes probably there are higher degree of frequency where vibration is going to occur, and it is it is on the development stage of a discussion with the engineers, or how is the vibration they're going to expect, and this connectors needs to go through those vibration tests, because for a connector itself we need to do at least a testing with a simulation as much as possible near the application. So this is where on the development stages, and a creation of test plan is very important for a good reliable connector. So this needs to be, because there's a big or a large range of this vibration settings. There are lots of levels of also on vibration setting, which maybe it's too much and we don't need it. And maybe it's too low that, yeah, it's too low. But this is something that for the development stages, it's something that needs to be discussed together.
Mhm.
They are good points. They are important points.
Understood.
Yeah.
Understood. And do the connectors have fire resistant properties?
Yes. Yeah. So there will be degrees of fire retardancy for all the connectors. This is one of the basic requirements for a connector first. So for fire retardancy, there sometimes they're talking about more on the UL type of safety. So it means that the plastic they're going to be using needs to be distinguished, or I mean extinguished. Once the connector gets the fire, it's going to extinguish itself. So
Okay.
based from the test, first thing we need to avoid fire. But the second, once it gets fire, it needs to extinguish itself. So yes, for some instances, if a connector needs to pass with a certain flame resistance standard, it needs to go through this type of test. This is not just test, but also you need to choose the correct material for that.
Mhm. Understood.
Yeah.
There are a couple of questions about testing that is done on Chogori's connectors. If you can share any information, though you did share a test plan and the standards you go through, but there is a question specific to a testing that is done to ensure the connectors work in Indian conditions. Or when you work with the OEMs here, what type of testing is done alongside their products to ensure the suitability for Indian conditions?
Yeah, about this is it is something that we are currently working. It gives us a good insight for Indian conditions. Um, whenever we whenever we work together with Indian engineers, it gives us very good knowledge also. And unfortunately, some of the standards that are in place are not in par on that current requirement, actually. So some of them, yes, it can meet, but some of them are not. So, um, but for now, this is how we work. Um, we have a present. We can present some testing standards that are available, because now we're using an automotive standard. But as you can see, this automotive standard is something different or maybe implemented in another country, but a good collaboration with engineers, Indian engineers to meet their expectation is very good. Also to put all these together and give a good connector. But unfortunately, for a Indian type of standard, it's not yet available for us to follow.
Maybe just to add on the on the US car 237 test metrics. The test metrics is actually available online. So we have that as a reference, number one. But in the course of development, we also work with the end customers. Okay, what else may be required beyond what this metrics is currently saying? So we have different customers in different market segments that will come up with something in addition to that test matrix. So different customers, we have got solutions for wired ones, we got solutions for blind mates. Along the way, yeah, there are very specific requirements, but those are very confidential, specific to those end customer. So we will work along those guidelines based on what they need to incorporate into our whole test plan.
Okay.
Yeah, there's a question here from Prem Kumar. Okay, he's saying that apart from connector, the cable harness which is being provided shall be capable of carrying the rated current. Yes. Is cable provided is fire retardant? Yes, it is fire retardant. What is the temperature it can withstand? Okay, the temperature that it can withstand, this will be depending, number one will be the requirement itself. So how much temperature are you going to be requiring once this cable is inside the vehicle, for example? So different types of cable material will have a different type of temperature rating. So for example, if you want this, if the battery itself goes up to 200 degrees, for example, then it is recommended to use something like a Teflon type jacket or a silicone type jacket. Okay, so those are just some of the points that I can share to Prem. Okay, so the other is, hello, Dominic, can you elaborate the polymer chemistries? A question from Rath. For insulation of cable, since rain and moisture pose the greatest challenge. Yes. So yeah, so this is more on the cable construction and chemistry on the cable supplier side. So actually from us, we're just going to get our cables from our suppliers, but of course we also need to know the construction information so that the cable itself, what we're going to do is that we need to make sure that the cable bonds very well with the connector. We're going to manufacture the connector, do the overmold around the cable, making sure that the overmold is bonding on the cable jacket and no moisture can seep in. Okay, so for the chemistry on the cable materials, I'm not so sure about that. So I hope I get that helps. Okay, the others, in battery swapping solution, is there a cut-off mechanism to avoid overcharging of the batteries once they are full? Okay, so yes, there will be a cut-off, but like I said earlier, from these type of issues on how is the charging going to be, it will be based on the system itself, the battery system. The system needs to have an integrated circuit, which they call a battery management system, that is going to take care of these issues. So there is also one question earlier that I have answered, where they're asking if the connector, how are we be able to avoid sparks once you're connecting the connector to the battery, for example. Okay, so the sparks, I think he's asking this because of you're going to connect the connector to the battery under load. It means it is energized once you're connecting it, the connector to the battery, it is energized. So there are some instances that this needs to be discussed into the development, because we don't want to have any sparks once you connect these connectors together. So in the development stages, there are some points that sometimes the design of the pins, one of the signal pin needs to be shorter, for example. So it means that one shorter pin is going to be used as a wake-up line, where when you connect, the power pins needs to connect first, and then the signal pins is going to connect the second, and then the shorter pin is going to connect last. So the shorter pin is going to wake up the battery, but once it wakes up, it means that the power is already connected. So there's no initial surge of electricity that's gonna cause the spark. Okay, so just sharing to you guys about that one.
Yep.
And then go ahead, Kelvin.
Yeah, Dom, you're done with this, because I'm looking at one question that is quite common that I want to also address that particular question. You done with this one? Okay.
Yes.
There's a question I'm reading at the moment from Mr. Anuj Singh. It would be good to know the challenges in bottom fit connector in the two-wheeler. Okay, this is a good question. Yeah? We have evolved a lot of this kind of solution. First and foremost, I say again, because we built our own contacts. So, and then our contacts are also being very rigorously tested by the current major customers in India at this moment. Okay, you have seen the presentation earlier. So there are different challenges doing this kind of solution. We have evolved almost like 20 different models already. And each and every customer requires something different. They want certain customization. They want certain ways that the cable runs inside the battery, or the way that the cable runs on the scooter or on the charging platform. Now, there is a lot of iterations that need to be discussed very closely between both companies, us and the OEM in the development, because a lot started off putting the entire weight on the connector. The connector fundamental function is to transmit power and signal. It's the same like back home, if you were to plug in an AC, you don't put load, you don't put pressure on that connection. But the problem is now we're having a 10 kilogram battery directly on the connector. It will be a big problem. So there are ways to go around it in terms of the allowance, in terms of how the battery casing should be designed, including also stoppers and within the battery case itself where the battery sits, so that everything is taking the full weight and the connector is doing the function of transmitting the power and signal, or for this case, the discharge. Okay, so that there is a lot here that goes beyond what you see in terms of the development phase. Okay, yeah, just to answer this question, this is a good question.
Thank you. Thanks for picking it up, Kelvin.
Yeah.
There are some questions particular to Chogori's offerings. Does Chogori have a connector for 400 to 500 amp 72 volt panel mounted IP rated? So very specific questions. If any, so we are almost through with the webinar time. So I would just quickly reiterate that we have shared the email addresses of Chogori's team on the chat. I have shared Kelvin's email address, and Elena and Bobby, who are representing Chogori today. I will put them on the chat again. So please feel free to connect with them in case any of your questions remain unanswered, or you have any other questions about offerings or product catalogs, or have a more detailed, deep technical discussion about your requirements. So please do that. There are a couple of requests for the PPT. The PPT we won't be able to share. It's a proprietary Chogori material, but we will let you know in case we are able to put up the recording on publicly. In that case, you will be able to go through the contents of this webinar again. So we will confirm that to the participants via email after this session. So Dominic, is there any other particular question you would like to pick up before we wrap up the session?
No, I think that's all.
Yeah.
Priyakshi, thank you very much.
Okay. All right. Thank you very much, Kelvin, Dominic, again, for taking time for this, preparing particular presentations. As we, I remember I gave you a lot of feedback and instructions on what, we think will be an insightful piece of content and what all kind of information our audience will appreciate. So thank you very much for putting in that effort and bringing that all in front of our audience today. I really appreciate it. And thank you to all the audience members for participating so actively and asking good questions and making this an informative session for everyone. Thank you so much and have a lovely evening. Bye.
Thank you. Thank you all. Bye-bye.
Bye.